that moves through a material or vacuum. No, so in a simple language, what do you mean by wave? So wave is the disturbance that carries energy from one point to another. It means that this is the wave, and this is the wave, and here are some particle. This is the particle, and the particle is disturbed by some patterns like this, and this pattern is, and this is the disturbance pattern, and this is the disturbance pattern. Okay, all right. So we'll be talking about the progressive wave. So what do you mean by progressive wave? In a simple language, is a wave that move through a material or vacuum is called progressive waves. So waves that moves through a material or vacuum is called progressive wave. So suppose imagine that you are moving in a space, but it's a vacuum, but there is a wave, and that is the light wave. Basically we study about the light and sound wave in physics. So there are only two kind of wave, I guess. So besides there are two main groups of wave. So there's two main groups of wave. So one is transverse. If the disturbance takes place perpendicular to the direction of propagation of the wave, the wave is called transverse wave. So it's kind of like this, and you have studied that. So talking about the transverse wave, if the disturbance takes place perpendicularly, and these are the perpendicular, this perpendicular to the direction of propagation, means naturally created. This is the direction propagation of the wave. It's called the transverse wave. So this longitudinal wave. So in a simple language, a longitudinal wave is kind of like this, you know, and it's rarefaction, and this is the compression, and this is the compression, and this also the compression, and this is the scatter part is called the rarefaction, and these are the rarefaction. Okay, and then after so what do you mean by longitudinal wave? So if the this alright, sorry, if the disturbance is along the direction of propagation of the wave is called longitudinal wave. So about the longitudinal wave, so what you can say about the longitudinal wave is the disturbance along the direction. It's a disturbance. Look, here there's some disturbance, and along the direction here is just some kind of disturbance. In some part it particularly get refracted, and in some part it compressed, you know. And is longitudinal is, you know, longitudinal means horizontal. In a longitudinal means like this, you know. Yeah, and these are the longitudinal wave. All right. So we move to a second part of wave, and that is about the oscillation. In a perfect manner, how do we define waves? And we simply define a wave is made up of oscillation. It's made of oscillation. So basically, oscillation means when a wave is completely in one cycle, and from A point to B point, and from A to B, it is one oscillation. Understood? So this is the one oscillation. So when the wave have one cycle, which can also be said as one oscillation. So a wave is made up of oscillation which cause the displacement of a point from its equilibrium. And this is the equilibrium point. This is the two equilibrium point, and these are the equilibrium, you know, and these are the equilibrium. And so it has two equilibrium point, and it's also the displacement. Look, it's also the displacement. It is a maximum it is a maximum displacement of wave, which we'll be studying in next chapter. Okay, so this is the about so on next chapter, so we'll be moving to the amplitude. So in a logical way, what do you mean by amplitude? So in a wave, amplitude is simply it is a magnitude of maximum displacement. This is the max displacement. So max displacement, and this is a magnitude. This is the magnitude, you know, it goes towards so how do we say about the amplitude? So amplitude is the maximum, no, sorry, it is the magnitude of maximum displacement from equilibrium of a point on the wave. So we discussed about the magnitude and maximum displacement, but also I discussed about the equilibrium point of the wave, and these are the equilibrium. So this is also the amplitude, this is also the amplitude, this is also the amplitude, and this can be also say, and this is also the amplitude. Don't get confused saying which are the amplitude. So amplitude is the maximum displacement, but it also has negative maximum displacement. This is also negative maximum displacement, you know. This is also like this, okay? So don't get confused in amplitude. What do you mean by wavelength? You know, many of are getting confusing about what is wavelength, you know, and they said like wavelength is from the you know, equilibrium point to adjacent point, and these are the wavelength. But these are also the wavelength from this point, you know, from this point you can say like you can also say this is also wavelength, you know. So don't get confused, it has to, you know, from to adjacent point also you can say it's wavelength, and from the origin point to also this one complete cycle also it can say it's a wavelength, you know. And as I had already spoken about the you know, this is the A to B, from A to B, it is a one complete oscillation, one complete oscillations. Like that. So what about the wavelength? So how do we define wavelength? If somebody say me about the wavelength, so you know, basic language, you can say the length of oscillation is also called wavelength. It's the length of oscillation, is a one oscillation. You can also say the wavelength. Alright, so talking about the, so there is also another perfect definition for the wavelength, and that is the distance between two adjacent points on the wave that have the same displacement and velocity at the one instant. And this seems like quite difficult, you know. So what do you say about the velocity, you know? So in a wave, if there is a same maximum displacement, and this is the, suppose A or B, and this is a two adjacent point, and when there is the maximum, when the maximum displacement of A and B are equal, then the velocity is said to be zero, you know. The velocity is zero, you know, and it is in one instant. The velocity at one instant, you know, is one, it's not changing, you know, not the change, it is, the displacement is same and displacement is same, and the are equal. Okay, so this is the amplitude. So here are some things that you need to know before knowing about the wave. So the main part is about how you will mark wave in a graph. So first of all, you need to know about the origin, and displacement is always at y-axis and distance is at x-axis. So if somebody make wave, then how will you describe? So this this is the positive maximum displacement. This is the positive maximum displacement, and this is the amplitude. This is the amplitude, and this is also the amplitude, and this is also the positive maximum displacement. But this B is negative maximum displacement. Negative. This is the negative amplitude also, and this is the negative maximum displacement. All right. So, and about the oscillation from A to B, this is the one oscillation. From A to B is one oscillation. So from A to B, it is a one complete cycle also. One cycle and one oscillation. One oscillation and one complete cycle. And talking about the how we'll find out the wavelength is from maximum A to maximum C. These are the two adjacent point, and you can suppose from here to it is a 50 and here is 10. So how will you find the wavelength? You'll find wavelength by calculation is 50 minus 10 because 40, and the wavelength is 40. All right, so if here is a mark 2, then you can say the amplitude is 2. So these are the things you'll have to know about the wave. All right.